Good evening, everyone. Jason here for JEHC, and we are getting back to our front suspension IFS design stuff. Tonight is going to be volume 8 of that, and we had a nice little outline to go through with that. So we're going to be discussing a few upright stuff left over from previously, and we're also going to be discussing some portal stuff, a few other bits, but yeah, that's about. I think that's be a good episode right there. Maybe a little shorter than some of the other episodes in the past, but for the most part, I feel like pretty rad. So let's get this ball rolling. So the last thing I filmed, etc., was the players fuckery, which turned out to be rather interesting. So after that episode, definitely had an impressive amount of positive feedback. Kind of like only one, or no, like a few people were upset, but really only one individual kind of was running their mouth. But otherwise, incredibly positive feedback, which is not exactly what I was expecting. But the reality here is, back when I was younger, it used to mean something to have a score tag. It represented something that even the guys, and I'm guilty of it too, and a lot of guys I know are guilty of it from 10 plus years ago, is we would go get score tags on vehicles just to say that they were score tagged as a point of pride. And honestly, like, you could sell your pre-runner for more too, etc. And nowadays, that tag basically is fucking worthless. it's mocked more than anything, especially with this Polaris thing. I mean, that really just showcases like how far it has fallen safety-wise from the days when, Savage ran it with like an iron fist to make sure that no fuckery occurred. The reality is, I'm willing to bet that Savage would have had those Polaris engineers, like, he would have sent them home crying. It would have been pretty emotionally devastating for them if they would have showed up and had Savage actually tech those cars. But, times change, things change, and thankfully, it seems that there might actually be some change now to score. And so after that episode aired, Norman himself called me. We had a decent conversation, a few hours that we talked about a few different things, the Polaris thing obviously being the main aspect there. I also got in contact with Dan Cornwell from Tech Director for Score. And although, long story short, Norman was really appreciative. I thought he was going to chew me out for kind of, being a jackass that I tend to be sometimes, but it was quite the opposite. He felt as though, in essence, he was very thankful I spoke out. Someone finally said something that now it's on his radar, and that to some degree, I may have saved some lives. And that's just the reality here and the primary reason why I did that. Because some kids are going to take what Polaris did and think that that is appropriate, etc., and build their cars in that fashion, or other builders, and that's just not acceptable. We have to nip that in the bud, so to speak, and call it for what it is. It's unsafe, and it's a joke, frankly. So, fortunately, after that, there were some more discussions, and Dan and Norman, in kind of a roundabout way, or however you want to put it, had asked me to put together my thoughts on updating the CR33s. And for those of us who do design chassis, actually design chassis, etc., the CR33s are kind of like that fundamental guideline that Score has had for, since Savage was there, etc., on chassis design for safety tech related cabin compartment, or what we call occupant compartment. And so, long story short, and I'm not going to dive into too much of this today, but I put together an entire update to the CR33s with all my thoughts, concerns, and what I want. And it went from, the CR33s being, in essence, like 3.5 pages to about 14, 15 pages of rules. And so I will film a whole nother video that just focuses on the CR33s and my thoughts with that. And this is kind of like a living and breathing document. A few weeks ago, or a week and a half ago, something like that, I submitted it to Dan at Score Tech for review. And even since then, I have talked with several other builders and guys that are, you know, my peers, etc. And I've made tweaks to it since. So it's not a final thing. It's like a rough draft, a living and breathing rough draft of an update that is long overdue for the CR33s in what I would call my side of the industry, chassis design development for off-road racing. And so I'll do an episode probably next weekend on that, and I'll probably even have some more additions and edits to that in the next 7 days or so. So let's move forward with the IFS design, Volume 8. And so we got past that. Oh, real quick, I had a question. Two builders asked me this, and same with like the guys in my shop, etc., about this specific picture that I posted the other day. And what that is our trophy truck chassis, the new all-wheel drive that I'm building. And the question here was revolving around what you see in red there. And what that is the Dakar Jack, in essence, the jack system for when we do spare tire changes, etc., etc. And this is the 34-inch model, which will be normal for trophy truck-esque applications, 6100. And what I was getting asked is, two individuals actually informed me that I had mounted these incorrectly in the chassis. And although the mounts aren't in there, that wasn't the concern. The concern here was that it's not leaning inboard. In other words, the top of the assembly is not leaning inboard to the center of the chassis, and the bottom isn't leaning outboard. And, well, I informed them that despite what they had seen some other guys do, etc., technically the correct way to mount these is leaning in a fashion where it's actually the top is leaning outboard of the chassis. And the reason for that is very straightforward. So let's dive into that real quick. Because I did explain this to several individuals over the since I posted this a few weeks ago. And so let's just do a quick review on my thoughts with this and how that works relative to mounting these in the chassis. So real quick, let's go to what these are. There we go. So this is a Tisco trophy truck. Tisco, great builder. Really like their stuff. They got a good group of guys down there too. And with like what I'm doing now, building these unlimited class vehicles, etc., especially like our new trophy truck, it's an honor that I get to compete against guys like the Tisco type stuff, because they do build really nice stuff. It's always impressive. And I'm not going to kid myself. I would love to own a Tisco. I just can't afford one. But I can get paid to build stuff to compete against them. So next best thing, I guess, for now. But so what you're seeing here is the truck with the jack deployed, and the deployment of the jack is lifting it up in a fashion so that what you can do is change tires, check shit that may be wrong, maybe replace a drive shaft, it's a suspension component, you know, various different things, because more or less, as you can see, it's creating sort of like this tripod effect with the opposing side tires still on the vehicle and the jack lifting the vehicle up. And this is absolutely phenomenal in the field. And great for these style of applications, trophy truck, 6100, etc. Now, in my Class 1 that we're building, we did not have room to fit these, so we're not running these. We're running more of the Geyser bottle jack deal. But regardless, we do have these in the trophy truck, and like I'm saying, I mounted them that other way, so to speak. And I was told that was incorrect. And, well, that's not correct. It's actually correct to mount it the way that I did. And here's why. So in a lot of chassis, you will see them mounted like you see here on the right-hand screen, which is in red, where the top is leaning significantly inboard and the bottom is leaning outboard, so to speak. How I mounted ours in our trophy truck is the inverse of that, and it's actually a little bit more like 6 degrees or 7 degrees or something like that, with the top leaning outboard. And the reason for that is when you look at the diagram below, what you can see is the truck then obviously lifts up and tilts. And so when that tilt occurs, you can see how extreme the angle gets on the jack in red, where it's mounted with the top inboard. And now if you understand anything about these sort of hydraulic assemblies, or a shock, for instance, like a bypass shock on these trucks or vehicles, as you extend outboard, so to speak, or extend the shaft, the piston inside the housing, obviously comes down through the housing as well. And then that distance that the piston rides on the internal of the housing and the end of the shock shaft is exposed from the housing decreases to a small amount. So you get a lot of leverage, so to speak. Leverage, you know what I mean? In that situation, hence why it's not difficult to bend shock shafts if leverage in that side manner is applied to, say, a bypass when it's fully extended. So that same concept, engineering principle applies to these, and anyone that's been underneath a truck where they're mounted in the red fashion, so to speak, you will damn well know what I'm referring to when you see these fuckers banana, because they do. It's sketch as fuck. It's a little concerning, but the point being is, oftentimes when you see them mounted in the red fashion, that doesn't necessarily mean that was done intentionally and correctly. Often we see these days that the chassis themselves were never inherently designed for a big jack like that to take place, so they're kind of stuffing them where they can get the wins, per se. And in that fashion, they are forced to do it based on how the chassis was designed, and if the seat mounting and things like that don't allow it to appropriately be mounted like I have in the blue scenario to the left of your screen, then the next best scenario, obviously, other than no jack, would be to mount it like the red. But if you are designing and developing a brand new race vehicle from scratch, I strongly suggest that you would mount it more like the situation I have here in the blue. And look at how much better, so to speak, that angle is at extension. That's going to be this bottom side over here. Look at how this guy right here is far more vertical and a better situation, so to speak, than this extreme angle of the red. And so that's why, like I was saying, is in this fashion, how I have ours mounted in my trophy truck, it is technically correct, but then again, I designed this chassis from the ground up to have that done properly with the seat situation how I wanted, with the mid-engine, with all of the other bits. So if you never intended for that to be in the chassis when you were doing the initial CAD work, etc., well, it can be very difficult to stuff that in as an afterthought, and therefore you may end up having no choice but to go with the situation over here in red, even though that's not technically the best route for this style of component. So that was just a quick little tangent to explain my thoughts on that and the specific reasoning as to why that is done. In my opinion, I feel like I have done that correctly, but that doesn't necessarily mean that anyone mounting them in the fashion that is red would technically be incorrect. There could be other variables in that equation, and it's usually, at least from what I've seen, typically revolves around that the chassis just simply was never designed with that intention. Because that's a big component to basically just shove through the whole chassis. So like you kind of got to prepare for that. You can't just fucking wing it, you know. And so this specific truck, this mid-engine truck here, I designed it with that intention from the get-go because we were never not going to run that. And so therefore, I got this to be in an optimized state for the application. So that is just our quick little side tangent on that fuckery. So no, I did not mount it incorrectly. And hopefully, moving forward, more guys will be mounting them in the more optimized position, create a little bit safer of a situation for these vehicles and applications. Yeah, so anyways, let's get back to it. We are going to continue on. And we're going to start with something I didn't have last time with me handy, and that was an EASM of this, which should be a upright there we designed utilizing a Spider Trax front hub assembly, and then that is a unit bearing assembly, and it's not a portal upright. It was actually a rear-wheel drive upright, but that specific client had a Spider Trax rear housing deal that ran, in essence, the same unit bearing hub on full floater housing. And so he wanted to run the same set up all 4 corners. And so what we did is we took our stage 2 like DIY upright and we just incorporated a builder belt into it and then matched the geometry appropriately to the wheel mount surface. And everything lined up just fine. So it's just a little something different. But I mentioned I was going to showcase this last time. Yeah, so there you go. Something that's a little bit more unique, but definitely doable. And, different strokes for different folks. And in this application, not too worried about. This guy is utilizing this, like I was saying, in the rear. And so now he's got matching components front and rear for his hubs and all those bits. So just kind of another way of doing, in essence, the same thing, which is building an upright for a rear-wheel drive assembly. Now moving on to keep going on the rear-wheel drive upright fuckery, we have Pro-Am. So I did end up going and pulling a few images of one of the classic Pro-Am uprights. So this right here is what a Pro-Am CAD looks like. This is a classic 5.9 clevis, 14 on 14, so 14 degree inclination, 14-inch spread. So this I would consider like a classic Class 1-esque upright, great for like the days of 37-inch tire Class 1s and possibly 39s. But this is something you could buy still to this day from Mackenzie's. It may look a little different. This specific model has got to be like at least 10 years old or more. Yeah, it's probably more than 10 years old now that I think about it from when I got this from Roy. But the point being is I just wanted you guys to see, because last time I didn't have this available, what the Pro-Am stuff looks like. And they don't really have anything online. But it's been used. I mean, many builders have used the Pro-Am stuff. And currently, I believe the Herbst trucks are still using Pro-Am uprights from Roy for those trophy trucks, etc. So the point being is it's kind of one of the originals. So you do see some of this stuff that has been done lately, these sort of clevises with that center pin type deal. And those are more or less like ripoffs of Pro-Am. And I'm guilty of that too. I've had clients where we've done something similar where they machine it themselves. Not simply because they thought they could do it better, but typically those situations end up in a factor of being a little difficult to get components from Pro-Am sometimes. Different strokes for different folks. So there's a quick glimpse of a Pro-Am clevis upright. And then here's another note of something I want to pull up and show for a rear-wheel drive. Let me go back to the Instagram. Search. It's kind of changed a little bit. Let's see if he has anything still up. And he does, Matt Walrath. One of the fabrication legends, to some degree. And he did it upright where the certified truck. RP Yarbrough. Good dude. Taken too soon. But I just wanted to show you how he did his upright with the blending on that specific chassis. And as you can see, he does a good job of, I guess you'd say, the artistic appeal to the fabrication. A lot of, see, like this blending of the through holes and things like that just kind of add a really nice touch. Now, obviously, it's more work, but what I'm trying to find is a specific upright where he did a sort of like a semi-fabricated / clevis bend deal to it. Blend deal to it. I'm sorry. That is it right there, I believe. I'm just seeing if he's got the images. There we go. So this is it right here where I believe this is, not a machine clevis. This was a fabricated clevis where these sides were plate work. Yeah, wow, it's just weird reading seeing Bryce's tag on there. So it's not a machine clevis, but the end result looked a lot like a machine clevis when he was done. And I don't know, maybe it was a story he posted at one point in time, but it's plate work that he blended together to make look like a machine clevis, and he did a really good job. Just another thing too that I've seen done where little bit more work because you're finishing it, you're fluff and buffing it, and making these sides look all bitchin' and everything. So technically not machined, technically fabricated, but that definitely looks like a machined, pretty cool piece. So there's just another way of doing things, and these are the, I guess you'd say, more traditional press-in snouts. For the front, they are 2-inch bearings. Like I said in the last, or volume 7, which I had to go back and read. Interestingly, and rewatch, because I had forgot like everything where I left off on, basically, to that last episode. It's been like 6 months. But what I was saying in the last one is this press-in deal, again, ID still does this, is a damn good way of doing these things. More importantly, a 2-inch bearing front hub on some of these bigger trucks is still totally fine. Not so much on the big all-wheel drives, but on like a 6100, like what this specific truck is, because this truck is still around. I'm trying to remember who has it now. Solon Motorsports, something like that. But anyways, yeah, so here's another good picture of that. And then you can see he just does a good job of fairly artistic welding, per se. Walrath does. And it does look good. He also, like, this was treated, clearly. Treated, and it looks like it was post-machine after treating, which, Bryce was, that's certified treating. That's who we use for all of our stuff, whether it's suspension and chassis. And I'm assuming, given that this was the certified truck, this was the same deal, that they had this treated too, at certified, etc., etc. But yeah, so again, different strokes, different folks, just another way of doing very similar stuff. And so now, let's dive into more upright fuckery and going into machined uprights. So we're going to go to rear-wheel drive machined uprights, and let's review some of these. Oh, cool. So here is Mason. But let's go into fully machined. Okay, so this is Armada / Triton. Don't remember the specifics of this image, but I believe Igor and Elliot, when they parted ways, they still have like pretty similar influences in design and style. There's another image of it. And so that chunk is basically 4130, maybe 4140. And then they're welding the steering tabs to it, welding the brake caliper stuff to it, etc. And so that is one big machined chunk out of chromoly. And that is definitely one way of doing it. Here is, and then here's one I did for a very heavy. These are for like a crew cab luxury pre-runner, this specific one. So built for a little bit different direction. Whereas the Triton Armada ones, they were done far more in lighter duty application per se, like a truck that's half the weight of this specific one. And this one is all machined 4130 with the integrated caliper bracket dealio. And then he welds on the tabs appropriately for the steering in this specific application. And this one, like I'm saying, is for a much heavier truck. These are for big pre-runners. This was a new front end for a client. And that was a specific request on that note. Another thing to note is, like, you can kind of see how, this steering tab gets, kind of in line with this crossbar and some of those other little characteristics that are in place to just add strength. And the weight on this ended up being not horrible, but it definitely was pretty stout. So, like, applicable for a very heavy, big pre-runner. But if I was building, like, a dedicated TT or a 6100, this might infringe on being a little too heavy, a little too much for that application, which is fine. Again, different strokes, different folks. And then, so example, here is a Mason Motorsports rear-wheel drive, two-wheel drive upright. These are machined, I'm almost positive, out of 7075. And there's an important note here on these, and that is the spacer on top of this upright. And so what you're seeing here is the spacer it's spread out very wide on the top of that upright. And the reason that is done is to help distribute load, because basically you have a big single shear application for your upper arm. And this is totally fine. This definitely does work, so it's not like it's bad. And this is an older truck per se, but I think Mason still does this or something similar on the newer rear-wheel drives or the Gen 2s or whichever gen they're on. And so when you can see right here too, see how wide that spread is on top of that upright. When Kiptech was doing theirs, and I was speaking with Matt about this, he had asked some thoughts about the spacer integration into the top of an upright. So basically, this is a 70-75 main body for the upright, and then this spacer you see up top / pin insert, because I believe theirs inserts slightly, is a 17-4, which is common for uniball bearing spacers. And you'll note that on the Kiptech one, they went very wide too to distribute that load. In fact, I literally, when I was talking with Matt, I sent him this picture. This picture, and I believe that picture right there to explain my thoughts on why and how to appropriately distribute that load. And, they did a good job. Arguably, possibly a little nicer job than how Mason did it. Mason's a little bit more rudimentary, not that it's a bad thing, just, a little bit different style preferences, whereas Kiptech, Ryan, Matt, they put a little bit more emphasis on some of the styling cues and characteristics. Whereas, like, Mason is obviously a little bit more just straight-up fucking race car, and that's it. And that's fine. Again, different strokes for different folks. These do work really well, these vehicles. And so this is more or less brand new. This is probably like 10 years old, maybe a little older at this point. But, yeah, just, again, another good example of machine. And then you also have, like, a vertical machine. So this would be like the Brenthel, which you can see kind of the front of the Brenthel right here. You can see the back of the Brenthel right there. And those are just big, solid chunks of 70-75 that just get egged out. They may be 60-61. I don't know what the Brenthel guys are doing, but they are fairly massive uprights. And be pretty expensive out of 70-75. But, again, these are relatively expensive vehicles overall. So it's not too far outside the realm to assume that most likely they are doing these out of 70-75. And so that's just, again, another way of doing a machined rear-wheel drive upright in a vertical bearing application as opposed to these others you were seeing. So that's a vertical bearing upper, vertical bearing lower, but this one has the upper arm that encapsulates the top and the bearing is in the upright, whereas these have the bearings in the arms. So, again, slight difference there. I hope I'm not losing you. And then these are obviously horizontal bearing setups. Horizontal bearing setup on the Kiptech. Horizontal bearing setup here. Horizontal bearing setup on this machine one I did as well. So just, again, different strokes for different folks in what would be considered rear-wheel drive upright applications. Now let's move on to all-wheel drive. All the cool kids are fucking with all-wheel drives now. Because apparently... if you're not, you didn't get the memo. That's the only thing you should be doing. But then again, I'm not the only one who believes that all-wheel drives are the competitive aspect for the unlimited class currently. And we're going to see some differentiation and some self-differentiation or selective differentiation, so to speak, with the fact that 6100, I believe, is going to grow. Had a conversation with Gordon, ironically enough, on this. And I do share similar thoughts on him with this, that 6100 will become a premier class because the budgetary constraint to be competitive in trophy truck or unlimited class realistically is now mid-engine all-wheel drives. And that's rapidly approaching. Hence why what I am building is a mid-engine all-wheel drive to compete in that realm. Hopefully, fingers crossed. Can't really say shit till it's actually out and about because, in the computer it's really fucking cool, but until it's done, it basically is just a big jerk-off fest. That's just the reality of how the industry works. But like I'm saying, the 6100 stuff is going to be insanely competitive. The Eclipse guys, they have brand new T5 that I designed going together. Really excited about this. Hayes family, and that is going to be hopefully good to go by middle of next season, starting to hit some serious racing. So they're going to get it together turnkey later this year, get some good testing in, and start hitting it hard. But I'm real happy about that. So again, and this is a relatively high budget 6100. I would say, if not one of the higher budget 6100s with what they are doing per se. But the point being is 6100 is getting to that point. Yeah, here's my all-wheel drive trophy truck. But you know, that's gonna be a thing where the all-wheel drives are $1 million trucks, etc. Plus the maintenance, the logistics appropriately to compete in that class is just upped the game so much that it's going to shift, or people are going to self-select down into 6100 to be more competitive. Whereas I believe San Felipe had 43 trucks this year in 6100, whereas the previous year was 36. I think I was talking with Dan Cornwell about this, and we were thinking next year is going to be above 50. I think that's realistic, given there's at least a dozen 6100s, if not 20 6100s being built currently that I know of. And so that class is going to grow and be a premier class relatively soon, whereas Trophy Truck, although a premier class, it's just instead of having the high numbers of entrants, it's probably going to get back to where we see a core group of like 8 guys that show up to be real competitive, maybe a dozen, maybe 15 on the high side. And that's just the differentiation between the sheer commitment financially to realistically be competitive in Trophy Truck. And that encompasses multiple avenues, from not just I can write a check, but you also have to think about the time spent with logistics and time spent testing, tuning, and practice, so to speak. Because, like, think of a guy like Menzies who can go and pre-run for weeks and go testing and testing and testing. Well, if you own a business, you're working, you know, in theory, a lot. It's difficult to, or if you're working, period, it's difficult to take the time off to legitimately spend all of this time focused on racing. I mean, it basically becomes a full-time job, and then you have like a side hustle of some work trying to make money when your full-time job is basically off-road racing. And there's a few guys that are fortunate enough to where that kind of is the case, or is the case per se. But the reality here is that's also a financial commitment, because if you think about, like, obviously if you're out practicing or racing or whatever, like, you're not out making money to go do that. So the financial commitment is way past, can I just write a check? It's also, can I write the time to be able to appropriately be competitive enough for these top tier and caliber guys? And that is both pretty gnarly and pretty interesting from where it was, you know, when, 10, 15 years ago, where it was kind of like Weekend Warriors were pretty much it. You know, it was all incredibly, independently wealthy, kind of like Weekend Warrior guys, whereas now we've got some pretty hardcore dedicated racers that, in the Trophy Truck aspect, this is more or less their full-time job, and they may side hustle some money. And so for right there, you have this pretty intense amount of financial commitment in time and just straight up money to be competitive at Trophy Truck, which again goes back to my theory that 6100 is going to be that growing class. Now, so with that said, this is where I'm going, that in Trophy Truck, competitively speaking, if you're trying to start a new program or build a new platform, you need to be looking at all-wheel drives at a minimum. And if you really want to be a stickler, I believe you should realistically only be focused on a proper mid-engine all-wheel drive platform. So that's going to be a Portal-esque, big block style, mid-engine platform, purpose-built for the unlimited class stuff. Not something that's, in essence, a chassis that's retrofitted into all-wheel drive, if you understand where I'm going with that. And so, with that said, let's dive into more on the IFS stuff with all-wheel drive uprights non-portal. Obviously, this is the less expensive stuff. Cool. So this is, I want to say this is Igor at Triton's deal. It's maybe Armada, but I'm pretty sure this is Igor at Triton's. And this is a front end that is a non-portal front end. I believe it's a Spider Track steel steering rack that is this geyser thing that they were trying to do. And all, I don't know. This is something weird. These guys were doing some weird shit with this front drive assembly that had a CV center point like 20-something inches. Massive. I've commented on that before. Again, here is another non-portal setup. You will see the lower arm is mounted below center line of, in essence, your hub and wheel assembly. So the axle is just going straight into a CV, into the shaft is center line of your quote-unquote hub. I mean, it's a little bit more complex than that, but I'm just trying to simplify it. So there's no gear set that's dropping that down in a portal, which we'll see here in a minute. And so here's one I did that's like a rock bounce racer deal. Again, Spider Tracks type assembly. These are for those Jake Berkey buggies. These are those buggies are pretty intense. If you've ever seen those, sorry, damn it, missed the boat on some of those. So let's go back. So that's the one I was referring to a minute ago. And I've reviewed all this stuff before, like a bunch in a few other episodes. So it's not like we haven't reviewed this before and stuff. I'm just kind of going quickly over it. Just so you understand what it is. The geyser. This is just an upright for another non-portal all-wheel drive front end. Same deal. Same deal. This is the Nelson all-wheel drive trophy truck that was a non-portal all-wheel drive setup front end. This is the Robbie Woods one, non-portal all-wheel drive front end. The diesel. This is the $1 million diesel thing. That's right. This was just a long travel deal I did for like a 2017 range Silverado. Again, non-portal, all-wheel drive. Same deal, that Silverado deal. Yeah, this is one of our like stage 1 non-portal Spider Tracks deals. Spider Tracks deals. Spider Tracks deals, again, non-portal. This is what that assembly looks like. This is like a plasma table friendly stage 1 setup. Just so you can get some idea of the non-portal stuff. And so the main thing with this, well, with any all-wheel drive that you kind of want to watch for is what's called CV walkout, or at least what I call CV walkout. I don't know if everyone else calls it CV walkout, but basically you'll have your inclination angle, and then you're going to have your CV at some point, in there. Now, this is looking straight on into the upright. And if that CV center point, or the rotation axis of the CV, in other words, in space where it actually rotates, so there's going to be a point in there that it does in a non-plunging CV. And a plunging CV has it too. It just manipulates more, so you got to pay attention to that. But my point being is, when you have your inclination angle, you're going to have, obviously, a point where that CV rotates, and you don't want that point, or that CV rotation center point, to be too far inboard or outboard of the inclination angle. Rarely is it outboard. Usually it's too far inboard. And so what that will end up doing is it's called CV walkout. And so what happens is, as you cycle the suspension in a straight line, you could be like, oh, there's like no plunge whatsoever. I've got it all dialed. But if you have that CV center point inboard of the inclination angle, a little, as you rotate and turn, what ends up happening is the CV center point, that rotation point, kicks out. And it's like walking out of that line. And as that walkout occurs, it's going to exponentially spike plunge. And if you're not paying attention to that, that can cause some serious issues at like extension and lock. If you've got that CV center point off of inclination any bit, I mean, like even like 40 thousandths can really start to bite you. If it's like an 1/8 inch, it's going to get exponentially bad. That plunge is going to, it's going to grow quickly. And so that's something you definitely have to look for when you're designing uprights and stuff. So where I'm going with that is, typically speaking, rule number 1 with like the all-wheel drive stuff is, you can't take a 2-wheel drive and then just convert it to all-wheel drive and then just hope for the best. Typically, when that happens, it's going to be a slew of issues down the road, because fundamentally speaking and inherently speaking, like the all-wheel drive characteristics that you need to have, such as the CV walkout, or basically the deployment of reducing CV walkout, is critical in my opinion, in other guys' opinion, etc., so that you don't run into these plunge spikes unexpectedly if you're not paying attention to the characteristics of what everything's doing through turn and travel, you know? And so to avoid that, obviously, if you're mounting that center point of rotation on the inclination axis, you know, then you're not really going to have CV walkout. There'll be some tolerance building and stacking and the components, etc. But, you know, it's not going to be much. And that's what you, in essence, want to avoid if you can at all costs. Now, let's go to a few different examples in this. So we've got this Spider Tracks. Let's go back to like the Igor setup. I don't have a great picture of Igor's. Let me see if I have a better picture. Not really. Oh well. The point being here is like here's a little bit more of a fabricated, a little nicer of a fabricated one, where it's like one of our stage 2 type setups that's a little bit more complex. Whereas like this guy right here, you know, this is a stage 1 uprights, this guy, and it's far more simplistic. You know what I mean? These are just straight tabs off of, this is a builder bell that you buy from Spider Tracks, and you're more or less just kind of putting flat tabs off of that in like sort of like a semi, you know, Oreo fashion like we have seen in other arms and things like that. For more complex applications, you can see more intricate plate work and things like that, like what Igor did here, where I believe that is a Spider Tracks housing, and then I think they're machining that out, as you can see if you look closely, to kind of give some clearance where clearance is due relative to some of the bits. And then he's got a little bit of like a nicer / more intricate plate work on those bits too. But these are a little bit more of a nice fabricated part as opposed to like what I was showing on those stage 1 bits where they're kind of like more ground and pound, a little bit more rough, so to speak, where they're like plasma table friendly stuff. This is definitely all CNC laser cut, CNC bent. They do a good job TIG welding all this stuff together, etc. So a little bit different application, different strokes for different folks to some degree in that. The Geyser one, again, very simple. Even like the like this is the Jake Berkey one. Like those are just, you know, a little bit more complex in the upright than like just the straight tab one like I was showing from like the stage 1 stuff that we had. But even with that said, like this one right here, these are just standard, you know, builder bells from Spider Tracks, where we aid the back out a little bit for clearance, etc. But it's nothing crazy. And then that type of stuff is going to be all 4130. Like I don't have the picture of Robbie's, but his is very similar. Same with like the Illumicraft is also very similar. They're far more like Pro 4-esque, the Illumicraft all-wheel drive buggy. I don't have photos of that. I probably should have put something together, but if you've ever seen Pro 4 stuff or understand any of that, they're not unit bearings to some degree. It's more of a traditional hub type setup, a little bit nicer than the Spider Track stuff, a little bit more expensive than the Spider Track stuff. But a lot of guys do run Spider Track stuff without much of a problem. Like we've got guys that have run that stuff. I do like it, but at the same time, for nicer, you know, non-portal all-wheel drive type applications, like Pro-Am's got some stuff for that, and there's a few others, but it's going to be far more rare, especially these days with the fact that like almost all applications are going to portal setups for all-wheel drive. So you're probably not going to be seeing too much of the nicer variant of non-portal all-wheel drive stuff anymore, other than like kind of like Spider Tracks has that market pretty cornered, both for like even the Desert Guy stuff and the Rock Bouncer, you know, stuff. And where I'm going with that is because of companies like 74 Weld, etc. Like they kind of have a good lock on the portal game to where that seems to be where most of the stuff is heading if you are going to be spending the capital on an all-wheel drive. So you're kind of like going to the Spider Tracks route, etc., or you're going to be stepping into portals, is where I'm going with that. So that intermediary step of those like Pro 4-esque, really nice hub and builder bell-esque setups aren't really going to be around per se, or at least like I'm not going to be using them. I don't see a lot of other guys using them either. Unless like Illumicraft still builds a few more of those all-wheel drive buggies, they'll probably be using stuff like that. Oh, the Racer Engineering trophy trucks too. They run a non-portal all-wheel drive system. So that would be, again, another variant of like a Pro 4-esque or a little nicer version of Pro 4-esque stuff. Same with like the Huseman truck that was built for Menzies that is now owned by Potts. That is a non-portal all-wheel drive esque setup as well. That is, again, sort of like a nice variant of like what Pro 4 applications are. So yeah, so now let's move on to the big boy shit. Let's get into fucking portals. And there's some fucking wizardry in portals, and I love this shit because it's pretty rad. And I'm building several portal platforms, both Class 1 and all-wheel drive, and trophy truck all-wheel drive. So obviously I have been diving into this the past few years to kind of go through it. So let's go through some let me just look at my notes. Yeah, so let's dive into the basics of portals, because there's there's two basic layouts and then two variations of each of those. There basically is 4 layouts of portals that you will see, possibly will see, may never see. And I'll explain some of that. So let's dive in. Let's see here. PDF. Quinn sent me these, and I think I reviewed these at one of the other episodes, but I don't really give a shit. We're doing it again, so fuck it. You're going to have either a 2-gear or a 4-gear portal. And there's pluses and minuses to all of that, just like everything in life. Get the fuck out of here. Got it. And so here's a 2-gear portal. Now, this is a 74 weld setup. Again, Quinn sent this to me. So in a 2-gear portal, it's exactly what it sounds like. There are 2 gears. Here you go. Here's the layout right here. Now, this is obviously a lot more simple. And they are pretty much only selling these for the rock guys these days. Although, yes, Igor at Triton Engineering did do a 2-gear portal on the front of the ELE trophy truck, which is a converted older Porter truck, which has been given new life. It's doing great, but it does run a 4-gear portal now. Same thing that like the Brenthal truck runs. I did not get any pictures of that, but just to give you a little heads up. Also, Gordon does run a 2-gear portal, and I'll get into his specifics on his because he's got a patent on his, which I technically did not infringe on, nor and not going to, but I know exactly what he's doing. Blah blah. I did have a discussion with him on that, but this is a 2-gear portal, so you have the unlike what I was showing you earlier in the non-portal stuff, the CV is on center line of the hub assembly. So the lower arm obviously has to be mounted below that, etc. Now in a portal, the gear set it puts the CV above the lower arm. So now the lower arm can be mounted just like a traditional rear-wheel drive application, where it is in center point, center line of the hub assembly, wheel and tire. And now the CV is raised up above and then going in. So let me pull a picture just to reference that real quick. It might help with understanding that a little better. Let me see if I've got... I'll find a file here that will make more sense. We can use one of the Mason's examples. There we go. So lower arm here is in line with the hub assembly and portal. CV up here is up above. And so in a non-portal setup, your hub is going to be up here, and then your lower arm is up here. So you lose ground clearance, you lose some travel, geometry characteristics kind of like are meh, especially at extension, because the CV angles get a little bit meh. And that tends to be the problem. So like a portal solves multiple issues on top of the fact that like you do get that gear reduction, and that is definitely a plus for multiple reasons. And so in this application that is Quinn's deal, the Spiretrax unit bearing type portals, and that's what 74 weld is, they have the 2-gear. And so the 2-gear is you just have your main, and then you have, you have your input, and then your main, which is your output where the hub is. And those are the only 2 gears. And it's simple, etc. You also have to keep in mind it is a reverse rotation. So now the front differential is spinning inversely to the wheel and tire, so to speak. Whereas on a 4-gear, because you have 2 idlers, and we'll open that right now, you spin the same. So when you have a 4-gear versus 2-gear, your front differential is going to be spinning 2 different directions. There's no way to get around that. That's just a part of 2-gear versus 4-gear portals. And so here are the gear layouts in the 4-gear portals. And as you can see, a little bit more complexity, but it's the same philosophy in that the CV, etc., is above the hub assembly and main gear. And so this obviously does provide a lot of cool stuff, primarily a little bit better strength. It's also, there's this weird caveat too, in that the 2-gear portals tend to transfer a lot more rotational leverage to the upper arm in the chassis and the upper arm pivots in the chassis. Whereas a 4-gear portal, it actually has less leverage on that. It's spinning in the same direction as the gear set / wheel and tire, but more importantly, because it's got the idler gears, etc., it is kind of, in essence, rotating on itself, as opposed to like fighting that upper arm pivot with the 2-gear, because it's an inverse deal and reverse rotation. So when you have the 2-gear stuff, you typically will see more force and load being transferred from into the upper arm into the chassis than you will on the 4-gear. The 4-gear, in essence, will operate far more similar load path-wise to like a rear-wheel drive application. Not identical, but it's similar compared to a 2-gear portal. So no one chew me out that, oh, Jason said that it's the same as a rear-wheel drive. No, it's different, but what I'm getting at is how it transfers the load and reacts is similar to a rear-wheel drive compared to a 2-gear portal. So a 4-gear portal too, also, like, Quinn's got different ratios. The ratio in my specific one is different than these, but that doesn't mean that there's nothing wrong with his ratios. It's just different. So in other words, we set up our gearing system all the way from the rear differential, or like in our class 1, the gearing in the transaxle. Obviously, all of that has to complement what we're doing for the front differential and the portal gear ratio. So you got to make sure you've got all of that in line. Otherwise, it's going to be a really bad fucking day when you fire the vehicle up and get out in the dirt for the first time. But yeah, so inherently, these are the 2 main platforms that we have these days. Now, someone might make something different. Who knows? But these are fairly robust, and it's pretty difficult to do anything outside of this, because even with today's stuff, these 4 gears like so, they are kind of already pushing the limit, man. Like, you really can't fit anything else into that wheel tire package. And I'm going to get more in depth with that in a second. Now, to complicate this even more and take this a step further, we've got what's considered angled and non-angled portal gear setups. And so, now that you can kind of see what's going on here, these are considered non-angled portal gear setups. Let's dive into angled portal gear setups. And this is where Robbie's patent comes into play and what he is doing. Angled portal stuff. Cool. So, yeah, let's get into some fuckery right now. So this is a standard 2-gear setup, and okay, let me figure out how I can explain this without confusing everyone. I hope everyone can follow me on this, because we're starting to get into some cool stuff here with portals. So this is considered a straight portal gear. The CV is parallel to the main gear, which is where the hub and wheel and tire are. So this right here is where the hub and wheel and tire are, so that would be straight to that and straight. So it's parallel. This is a 4-gear setup that is parallel as well. You can see the idlers are orange. Blue represents the input. Green would be the output or main, whatever you want to call it. This is straight. So you can see that even the idlers are straight. So what happens here is the CV is going to be parallel to the wheel and tire. This is what the 74 weld stuff is. This is what the Masons are. This is not what Gordon's is. And this is actually what I ended up going with on mine, and I will explain that here shortly, because I did do a 6 degree. I was dabbling with that and an 8 degree. But we'll get into that in a minute. So this is an angled 2-gear, and here's the side profile of the angled 2-gear. Now, to be fair, this is an 11 degree, and this is where we get into like what Gordon has. Gordon runs a 2-gear on angle. I believe it's 11 degrees. Last time I spoke with him, I was positive that's what he told me. And typical Gordon fashion, he does have a patent on this. And if I remember correctly, it's been months since I spoke with him, his patent is 11 to 14 degrees. I believe I had confirmation on that, but the point here is your CV is now angled up in the upright relative to your wheel and tire. And you might be thinking like, what the fuck? Well, the reason this is important is if you are a big fan of CPTC mitigation at extension. And what the fuck is that? Well, I spoke in depth about CPTC mitigation in, I think, episode 2 or 3 maybe. And what CPTC is, contact, patch, track with, change. So say that all again. Contact, patch, track with, change. What that is this distance here through travel changing, the distance in these red lines. So ride height is here in the middle. That's a certain distance. We'll just call that distance fucking A, right? And then when you compress the suspension, it's going to have a different distance, that contact patch center point, because it's the contact patch of the tire at the ground, center point relative to the center chassis. That distance is going to change. So that compression, we'll call it distance B, so that changes slightly, right? And then obviously at extension, it's going to change too, because these arms are on an arc. So it's going to want to suck in at extension and compression. That's just natural. You can't get around that with A-arms. No matter what you do, it's going to suck in at extension and compression. How much it sucks in and where that contact patch track with change is either increased or reduced is relative to what I call CPTC mitigation. Contact patch track with change mitigation. So Gordon, and myself included in some situations, are big fans of contact patch track with change reduction, mitigation, at extension, as well as compression. Almost every properly designed truck is going to have it at compression, almost all of them. And the reason you can tell is that you're going to see camber change at compression into the 5, 6, 7, 8, 9, 10, 11 degree range, right? So all the trophy trucks you see, typically, they are not just straight up and down when they compress. They're going to compress and come in like this. Almost all, well, anyone that's properly engineered. Let me rephrase that. And so what that is, even though the guys designing it may or may not know, that's contact patch track with chain mitigation at compression. And so that distance, that contact patch change, as the suspension compresses, as the tire leans out, even though the lower arm is bringing that point of the bearing cup inward, as the tire gains camber, that track with change actually doesn't reduce that much. The more camber gain you have at compression, the less contact patch track with change you end up with. That same theory and concept applies to the extension side of travel. So when you extend the suspension downward, you can bring your wheel and tire and have the wheel and tire start to camber out. Instead of it being very straight up and down, you have it camber out a little bit. Now, Gordon is a big fan of that. There are other guys that are big fans of that. And now, for obvious reasons, you're going to start to run into some bind issues, because now you're not only extending it out, in other words, bringing those arms down like you see in these bottom photos here. Let's zoom in a little bit. See that? But you're also bringing that tire and leaning it a little bit. So I've got a little bit of mitigation here, so I can have less of that distance change. Now, there is valid argument for this being good and bad, so to speak. So on the compression side, like I'm saying, almost every properly engineered truck is going to have contact patch track with change reduction at compression. Pretty much all of them. That is a standard. The real argument that we start to get into, arguably splitting hairs, no pun intended, is going to be at the extension side. And the reason why there's valid argument that it's not as critical on the extension side as, say, like what Gordon believes, is because if your truck is in extension, so to speak, I kind of call it the feathering effect. In other words, that tire is just feathering. It's not really grabbing the ground. It's not really providing traction, because at that point in time, it's not doing much. There's not enough weight deployed into that tire and corner of the chassis to legitimately have any real ramifications into the feel of the truck. And that's kind of where I think most of the guys' heads are at, other than some of the real diehard CPTC mitigating guys that demand it, like Gordon. And so when you do that, as you can see, that upright is starting to lean over. Look at that bad boy. See this one right here? You're starting to lean over, and his is even more than this. He runs more CPTC mitigation than I do in this one. This one's about 4 degrees, 4.5 degrees. He might be pushing close to 7, 8. So what he's doing to still maintain good extension travel is he's kicking the CV up in his all-wheel drive application so that at that bottom side, he can reduce, well, not reduce, but he can gain proper extension travel without compromising the CV or overextending the CV in a manner that's going to cause a failure. So that's what you're seeing here with what is considered angled portal gears. You following me? Okay. Now, let's look at so this is an angled 2-gear setup. So basically, there is an 11-degree difference between the top gear and the bottom gear. And so that meshing of the gears, there's some wizardry in that. I'm not going to lie. I'm not the expert on the machining of the specific gear tooth patterns. I rely on some other people smarter than me to do mine, or to do this in general, per se. But the point being is, they're going to be machined so that at that 11 degrees, they engage appropriately and obviously rotate and transfer load. Now, what I was working on in my applications and different than Gordon's, I was initially going to go with a 6-degree, but I'm running a 4-gear portal. So, and I didn't end up doing that, and I'll get to that in a minute. So on my application, I was actually doing this, this might be the 8-degree one. This looks more like the 8-degree one, or it might be a 6-degree. Anyways, the point being is, on the one that's a 4-gear, you actually split the degrees. So if it was 8 degrees of kick in the input versus the main gear output, there's actually only 4 degrees between the input and the idler, and then the idler and the main. So it's actually 2 kicks built into it, 4 and 4 degrees in the 4-gear portal one. And then that is going to get you a total of 8 degrees, and that's going to allow you to run higher CPTC, higher contact patch track width change mitigation at extension without compromising the CV. And when I talked to Gordon about this, he was getting in the mid-20s of wheel travel with about a 90-inch track width with a good chunk of CPTC mitigation at extension. And I want to say like 8, 9 degrees at extension. So he was really pushing that CPTC pretty high. But that's common for a lot of his builds and applications. Now, I ended up not doing that. I started this path. And the reason I kind of pulled back from it, well, I had 2 reasons I pulled back from it. One, I'm still not necessarily sold that the overcomplication of the angled gears in an idler gear fashion and cutting was a risk I wanted to take relative to these new platforms. I already have a ton of stuff that I am taking engineering risks in, and I'm insanely fortunate that the family we're working with is beyond gung-ho. I mean, fucking thrilled to do this. So I wanted to not take every risk I had in the book, and this was one of those ones because I didn't feel like I needed to. My setup is a straight 4-gear. This is where I ended up, and I ran a lot less CPTC mitigation at extension, but I did run a decent amount of CPTC mitigation at compression. I am right around 92.4 inches of track width, and I have right around 26.13 metal-to-metal inches of travel in the computer. I will strap that conservatively at like 24, so I'll be happy with that. And with that said, from full extension to full compression, there is less than a 2-degree difference in the CV angles at those two extremes. So in other words, if I were to kick the CV at all, in the application I have now, it's not going to benefit me. Because if I kick it too much to complement extension, I'm going to fuck myself at compression, which is arguably scarier. Because typically if you're at compression under throttle, you have a lot of load and force coming through there. Way more than extension. Extension, again, think of the feathering effect. See what I'm going with that? So I ended up backing away from my 6 and 8 degree the 4-gear portal design and going back to my traditional inline 4-gear portal design. So the current platforms I'm running is this. That doesn't mean I may not go to one of these in the future and deploy some CPTC mitigation at extension. I may, but I'm not necessarily sold on that. And I feel like that was a little bit too much of a risk I wanted to take in these brand new platforms. I already have a lot of firsts, quote unquote, that we're doing. We are the guinea pigs for all the brand new Hollinger gearbox stuff, transaxle stuff, etc. Arguably kind of a guinea pig for the latest generation of the new Albans front diffs. I also have done the geometry in a pretty radically different fashion than, say, like what a Mason is, etc. So those are the areas where I'm taking some risks in. The portal stuff that we're doing, and these are our own portals in essence. You know, there are designed. I'm not machining them in-house. We're having someone machine them. I'm having someone cut my gears for me, etc. So we will have our own, but it's not machined in-house. I don't have the machines in-house to do this. Is somewhere where I wanted to not take as much risk, and in designing the front end, we're fine. 24 inches of conservative travel is going to be fine with me. I'm not stressed on the CVs, etc. But at least you guys now have an understanding of what this is when it's angled versus non-angled. Now, here's the other caveat too. As you go to the angled setups, one thing that you do find is on a portal setup like this, you really start to squeeze the brake rotor, caliper, wheel mount surface, and even this is all high offset stuff, 6+ offset inch wheels. They really squeeze hard against your, in essence, portal assembly. And so when you start doing the angled stuff, even though it doesn't seem like a lot, so like let's look at, here's straight. So here's what I want you to notice. Notice like this blue gear at the top. See this sort of edge right here relative to this edge right here? Just notice that distance, and now look at the angled one. See how it closes that up? Several hundred thousandths. Doesn't seem like a lot, but that several hundred thousandths, in essence, was really fighting us on our rotor and caliper clearance. Really fucking bad. So, and here's where I'm going with this. This is possibly why Gordon, when he did his far more extreme angled, his I believe are 11 or higher, pretty sure it's 11 degrees, he ran the brakes inboard because he ran into the exact same thing that I ran into, which is this package really starts to squeeze pretty rapidly and forces you to either run like a fucking saw blade rotor. I mean, it wouldn't matter. The caliper gets squeezed pretty fucking bad too, but like, yeah, the rotors get squeezed. And we didn't want to go below 1.25 inch rotor for this application. And so, again, that's why I went and just stuck with something a little bit more traditional, quote unquote, with the straight 4-gear as opposed to going with an angled 4-gear and then shifting that. So maybe someday we might do something like a fucking 7-inch offset wheel, and then it would make something like this more viable. But then again, even with that said, like I still am very happy with where I ended up on mine. I like the characteristics of the suspension. We still have over 26 inches of metal-to-metal travel with a 14-inch shock. We'll be conservative in the 24 and change range at a 92 and change track width. I'm happy with those numbers to get us going on these first platforms. I don't know if I'm going to improve on that. I don't know if we're ever going to change that. So like I'm saying, I stuck with the traditional 4-gear just like this in our current all-wheel drive applications. So just to give you guys some kind of in-depth insight into some of the characteristics of these setups that are, you know, the 2-gear versus 4-gear, and then angled versus non-angled. So that's the 4 different setups that are kind of like the generic applications for portals. 2-gear straight, 2-gear angled, 4-gear straight, 4-gear angled. And so those are the caveats. And it obviously gets far more in depth in that. I just don't want to disclose more than that, you know, and sort of these rudimentary drawings to some degree, just so you can understand some very basic principles in that stuff. And so now let's review. So yeah, so 74 weld, obviously you can buy that stuff from Quinn, etc. The Brenthel trucks do run 74 weld portal assemblies. A fuckload of guys run them for King of Hammers-esque stuff, multiple different classes. The ELE trophy truck that Triton did does run that as well. I'm trying to think what else. I feel like I am forgetting some others, but the point being is, so that's one option. Another option is going to be, that's portal front end, not portal front end, angle portal stuff. We'll drive upright, that's empty. Inserts. Trying to remember where I had set. Yeah, let's look at some of these images. Here we go. Okay, so obviously Mason. Now, I don't know if Mason will sell this stuff, etc. You'd obviously have to talk to them. I do know if you buy the truck, you get them. This is Gordon's. And so he does not like any pictures of his stuff showing, so that's the only thing that you'll probably find on the internet, etc. I'm not really going to divulge anything else from this that he told me because, you know, I don't need to or whatever. Here's a good shot of one of our portal designs a few years ago, doing some FEA analysis on specifically in this situation, trying to delineate some of the issues we were seeing with snouts from some of the initials. This is a 74 weld 4-gear setup. This is the Jimco all-wheel drive truck. But that right there, that entire upright assembly, everything. So the whole upright body, the portal stuff that's inside of that hub assembly, the Brembo package, all of that is actually from David ID. Oh, and here it is right here. And no, I don't. I'm not going to show you pictures of his internals or anything along those lines. But he does things his own way. And so this is something that, in essence, Jimco purchased directly from David ID. You could, too. You could call him and buy this whole assembly, I'm pretty sure, if this is a route you want to go. And you can easily adapt that, use that, into your application. If, like, Mason, so there's another Mason. This is an older rev of ours. Our actual portal upright looks different. The ones that are on our cars these days. Yeah, this is definitely an older rev of a few different things. But you can kind of get the idea there. This is an older rev. This is a good example on some of the bits that go in with the spacers and the inserts, and I'll get to that in a minute. Again, this is an old rev of ours. I don't think I have any of the new pictures or current pictures of ours. This is back when we were kind of initially doing some of the design development of the all-wheel drive platforms. But you can get a good idea as to those. Yeah, and then let's go through those inserts. Yeah, let's review these, because I'm kind of a stickler on those, on what I like to see in that stuff too. Because you don't want the bolt going through the aluminum. You definitely want to avoid that. That's quite unpleasant. Can definitely fuck some shit up. So, for inserts, let's see here. So that's the main one, towers. Okay. Cool. Okay, so what you see here are 17.4 inserts that are machined. that actually both come in and pinch the bolt hole. And so this is how I like to do it right here. So you got these two inserts. They come from both sides. They meet in the center with like 2,000s. If you can get them to be like perfect, it's difficult, but it's doable to be just perfect, like maybe like 2,000s gap or something, maybe 4,000s, to where they just go into the upright like so, right there. See that? So the interior side has protection or that crush, so to speak, from the insert, 17.4, and this is a 70-75 upright. And then obviously the exterior side does as well. So that's what it looks like from the interior side. Now this red, I'll explain that in a minute. But the this is what you don't want to do. See this red one right here? The interior of the upright is to the left of this image. So that's where the spacer would slide in for the uniball. And the reason you don't want to do this is, granted, it's going to help with the crush factor, which is fine. But the reason you really want to do these inserts is so that the 17.4 of the spacer doesn't want to dig in to the aluminum on the edges. And no matter how baller your machining is, precise the fit, all that, they tend to do that. It's just part of how it fucking happens. So putting a spacer in like this red one, where it's only lipped on the outside, so to speak, is kind of incorrect or not something I would do. I have seen some builders do this, and obviously after a certain amount of miles, you'll start to see that spacer edging into the upright. It's just going to happen. The 17.4 is significantly gnarlier than the aluminum. So it's much better to have something like this, where you've got it on both sides of the aluminum as both crush and for protection of the spacer. And then, like, it's hard to tell in this picture, but the diameter of this spacer matches the diameter of that inset, so to speak. And then even like on the steering one here, we have the diameter of the interior spacer match the diameter of this. And then the spacer that goes on the top, it actually insets into this, so it's nice and flush. And that diameter does match the 12-point diameter, like an RPI bolt 12-point. So even though these have different diameters for the exterior, interior of the insert itself on the inside does match the spacer. So the key there is you're not allowing like a 17.4 spacer edge to dig into the aluminum of the upright appropriately. And that is definitely what you want to avoid. And so there's just another little tidbit on some of these bits that I do things my way, but it's not even like my way. This is shit I have learned from guys older than me that I believe do this properly. And what I want to look here is I had a note. I think Ryan at Kibtech, I think he made machined Raptor uprights. Let me see if I can find those. So that's an all-wheel drive Ford Raptor billet machined upright. I vaguely recall him doing this. And now I got to try and find it. That's looking like it. There we go. Yeah, so here's the billet uprights. Now, these are just one big chunk of billet. He does do the 17.4 inserts. These are 70-75. Kind of like his stylistic appeal of like these sort of, you can kind of see how he does the pocketing and stuff. That's kind of like his own little thing that he's been doing with a lot of link arms, etc., and other components. And so I think that might be some like consistency to his style. But the point being is, here's just another good example of a fully machined all-wheel drive. Now, mind you, non-portal, because it's a Ford Raptor, but an upright that he did for, I believe, a long travel, or these long travel kits, in essence, that he is putting together. Yeah, there you go, long travel kit. So I don't know who else is doing something this serious. Maybe Robbie Woods. I don't really follow Robbie Woods. I'm blocked, technically, from Robbie Woods. But this almost looks like something that Woods might pursue or do. Oh, yeah, so here's a picture in there. So, yeah, so there's another good example of another cool all-wheel drive application and upright. So, yeah, so we are... Oh, this is a short one tonight. A little over an hour into this one, and I think this is a good stopping point because where I want to go next is kind of away from uprights, and we're going into bulkheads, bulkhead construction, and things along those lines. So that'll be volume 9 of the IFS front suspension stuff. So, yeah. My name is Jason Elvis Hurd, and I think the next episode will be reviewing the CR33 updates that I put together because of my jackass Polaris video. Funny how the fucking world works. But so yeah, so I really appreciate you guys' time. Again, if you guys have questions, comments, concerns, or shit talk, you guys can always reach out to me via email, jason@jehcinc.com. That's Jason Elvis Hurd Incorporated.com. Or my Instagram, which is JEHC, or that's DIY Off-Road. Ha, I do own DIY Off-Road. That is right. My other Instagram, or like my Instagram, is JEH Consulting Inc. There we go. So this would be like what I do on a day-to-day basis. DIY Off-Road is the digital asset marketplace, so it's not really like me per se, although I'm the one posting it because I own it. But this would be me. Like, this is our race shop that I'm building the all-wheel drives and all that fuckery. But yeah, so you can go talk shit to me here. You know, message me, etc. Some of you have. It is fascinating because some of the stuff is pretty funny. Pretty funny. But yeah, or, admonish me in the YouTube comment sort of faggotry. That too. Anyways, guys, I appreciate it. Pitter patter. And volume 9 will be coming up, hopefully, in the next few weeks. I'm going to do my best to stay back on this every week or two. Thank you, gentlemen. Take it easy.